So what are some reasons you'd want to use authentication on OSPF? Well, first off, you authenticate the source of your packets, meaning you trust where the packets are coming from. Um, Another reason to use neighbor authentication through OSPF is it is a secure way to exchange routing updates. So route authentication is important because it mitigates the risk of being attacked by a machine or a router that's been configured to share incorrect routing information with your network. As kind of attack, it's used if you do not authenticate your route neighbors by tricking your routers into creating a router loop, or by placing the attacked router's routing table into your network, and this will greatly impact the performance of your network, and it could even bring it down. So using neighbor authentication, it enables the routers to only share information if they can verify that they are talking to a trusted source. And the way they do this is using a password or key. In this method, a key is sent along with the route being shared to the other router. The receiving router compares the key that it received to its own configured key. If it's the same, it will accept it. By using a hashing algorithm, the key is not sent over the wire in plain text where anybody could see it. Instead, it's calculated using the configured key. OSPF authentication can either be none, simple, or MD5. The authentication method none means there is no authentication being used for OSPF, and that is the default configuration. With simple authentication configuration, the password is sent over in clear text over the network. And of course, we don't want this because anyone who knows what they're doing can easily find that password and become a malicious attacker. And lastly, MD5 authentication. The password is hashed into an algorithm along with the routing updates, and it's sent over the link. And this is the most secure way that we're going to use in this demonstration. So now that we've talked about the importance of OSPF neighbor authentication, let's go ahead and configure it and see how it works. So on Dallas, we are going to configure the interface for our OSPF authentication. Interface 000. I'm going to use IP OSPF. Let's see what our options are here. Oh, there we are. Authentication is the one we want. And let's see what we have here. Null. We don't want to use null because that is not secure. So we use message, digest. All right. And then we will configure our key. IP OSPF message digest key 1 MD5, the algorithm being used, and the password's going to be secret1. All right. And as we see here, we've lost our adjacency to router 2 because router 2 has not been configured with the key and our dead timer has expired. So let's go ahead and configure router 2 with the appropriate key to see if we can get our adjacency back. Oops. All right. And let's see if it comes back up. All right, looks like we have not created our adjacency, and that is because our password does not match. So if we do all right, so we took the secret -2 off, and we will go ahead and put the right one on. And there, our adjacency is created. So we created authentication using MD5 on router 1 to router 2, or Dallas to Detroit. And now let's go ahead and configure our authentication for the next area. All right. Now let's configure. So we're going to configure 001. So on this one, we're going to use secret -23 to keep it separate from secret -1. This way we keep the keys separated by the area. And this gives us an extra layer of security in case one area becomes compromised. As we can see, we lost our adjacency again because Chicago has not been configured. And let's go ahead and do that. And bam, the adjacency is back. Now Chicago can talk to Detroit and Dallas. Let's go ahead and look at these authentications. So we'll do a show IP OSPF interface. Pipe include authentication. Well, that would help if I used the right interface. Let's try that again. And there we can see our authentication is enabled. And let's confirm this on the other routers. Go ahead and paste this in. There we have it for both interfaces, for both areas. And now to Dallas. So there you have it. we have successfully configured authentication on our OSPF routes. So let's just confirm that we still have that we can see our neighbors. So show IP OSPF neighbors, and there Dallas can see their neighbor, Detroit. Let's go ahead and do this from Detroit. And here we see Dallas and Chicago, which is great. And Chicago can see Detroit. So we have full connectivity. Well, let's go ahead and see if Chicago can ping the Lions and Cowboys just for fun. And they can. They pinged the Cowboys successfully, so let's go ahead and do Detroit Lions. Oops, that's the wrong IP. There we have it. Full connectivity. Okay, let's do a brief recap of OSPF neighbor authentication or OSPF authentication. We configured our interface with authentication message digest using the MD5, and we used different passwords or passkeys for area 0 and area 23. And this adds a different layer or extra layer of security. And this concludes my presentation. Thank you guys for your time.